recording. So section 8.5 is all about adding and subtracting rational expressions. One thing, remember rational expression is basically like you've got variables with a fraction, right? So one thing that's really important, if you just remember when you add basic fractions, you need to get a common denominator before you can add fractions or subtract fractions. Like for example, just like if we had 1/2 plus 1/4, well, I can't add these until I get a common denominator. So you'd want to multiply, maybe you could get a common denominator of 4. So like the 1/2 would really be 2/4. So then you can add these, it would be 3/4. So keep in mind when we're adding or subtracting these, we always got to get a common denominator. That's going to be one of our goals when we're doing these types of problems. Sorry. So one big concept we're going to start with is a least common multiple. That's what LCM stands for. If you ever see that, it's kind of like, I'm sure you've heard of a greatest common, like a GCF. A least common multiple kind of goes hand in hand. But basically, a least common multiple is the smallest thing that they both can go into or can factor into. So for example, let's look at question A. We'll kind of split this. So question A, we have 2x plus 4. And then we have this x squared minus x minus 6. So when you're finding your least common multiple, the first thing you want to do is factor these. So we can kind of see what they have in common or don't. So if you factor this first one, you could pull out a 2. That would be x plus 2 then. For this trinomial, you could factor that. What multiplies to -6 adds up to -1. That would be minus 3 x plus 2. So to get your least common multiple, basically, you got to write everything. Like it's basically like you want to get a common denominator. So you want to look first off, what do they have in common? So the only thing they really have in common is this x plus 2. So your least common multiple, basically, you're going to have to write everything that wasn't in common and what they had in common. So like you would write your least common multiple would be 2. X minus 3, and then what they had in common, you just write 1 time. Like, so that would be our least common multiple. Or we'll see when we're getting a common denominator today, that would be our common denominator. So basically, like what would you have to multiply the other piece by to make them all the same? Maybe I'm not wording that the best, but basically when you find your least common multiple, you want to see what they have in common. And you'll just write that a single time. And then anything that they didn't have in common, you got to bring down as well. But let's maybe look at a second one. And if you have more than 2 pieces, you got to basically look at all 3 of them individually. So for part B, we have x squared plus 3x minus 4. Zoom in a bit. We have x squared plus 2x minus 8. Oops. All right, a little bit. Let me just try and rewrite this a little bit smaller. So we have x squared plus 3x minus 4. X squared plus 2x minus 8. Then we have x squared minus 4x plus 4. Okay, so the first thing we want to do is try and factor any of these down. So like this first one, well, this one factors nicely. That would be x plus 4, x minus 1. This one, if we factor, it would be x plus 4, x minus 2. This last one doesn't really oh wait, no, it does. No, it does. Never mind. What multiplies to 4 and adds up to -4? That would be x minus 2, x minus 2. Or you could write that as x minus 2 squared if you'd like. So we want to see, first off, what do they have in common? Well, honestly, none of them, they don't have anything in common between all 3. Like you'll notice some of them have the same pieces, some of them don't. So when we write our common denominator, like our least common multiple, sorry, It will end up being our common denominator when we get to later problems, but our least common multiple, basically we got to include everything we have amongst these three different like pieces. So we have an x plus 4, we have an x minus 1, and then we actually have 2x minus 2. So if you want, you could write that out as two separate things, or if you want to combine that, like you could also write it like this if you'd like. You could write it as x minus 2 squared. But that would be our least common multiple. Since none of them had there wasn't anything in common between all of them, basically we just wrote every unique piece we had, if that makes sense. But if you have something in common, you just write it a single time. Like you don't have to put 2x plus 2's like we saw in this first example. But and we'll see that, like, hopefully this isn't too bad so far, but basically we'll see what we're doing right now with this least common multiple is really how we're going to find our common denominator when we're dealing with these different fractions that we're adding or subtracting together. Basically, you just want to see what the other part has that one part doesn't have, and then we'll have to kind of work to make that our common denominator. Any questions so far? Because I feel like I was a little bit, how I worded wasn't probably the greatest, but hopefully you're seeing at least it, kind of how this is coming together. But we'll see when we get into some more problems. Okay, so we're going to look at some problems where we're going to either add or subtract rational expressions. And basically, we're going to see that we're going to have to find a least common denominator, which we'll see is basically the same thing as the least common multiple that we saw in this top section. So we've got two problems here. Maybe I'll do the first one, maybe have you try the second one. Let me see if I can zoom in a bit, but I'm just going to copy this problem. Okay, the first thing you want to do is always factor your denominator. I'm just going to abbreviate that. But you always want to factor out the bottom of your fractions. So if we do that, I mean, like the first expression, we can't do anything there. But for the second one, you could factor out an x. So if you think about what would the least common multiple be, I mean, you don't have to like really write this out, but like at least in your head, I mean, what's this part missing from this part? Well, it's missing the x. So our least common multiple would be this, x times x minus 1. So the second expression already has that least common multiple or common denominator, but we have to change that first fraction so it has the same denominator. So what we have to do is just use a different color. We're going to have to multiply this fraction by x, and if you multiply the denominator, you have to multiply the numerator as well. So once we do that, basically you would just distribute that x into the top. So you would get x squared plus 1x all over our least common multiple. So here, maybe I'll just, oops, back to red. But that would just be x minus 1. The second fraction we didn't have to do anything with because it already had that least common multiple. But sometimes you'll have to multiply both fractions by something. But now we can just add the top. So we can just kind of, now we can add these together. So I would really just have one, so it turned into one fraction, we would just have x squared plus 1x minus 2 all over our common denominator. And that's really our answer, but one thing we want to check is we just want to see, can we factor the numerator now? Because some things might like cancel out, it might clean up a little bit. So you just want to factor the numerator if that's possible. In this problem, it actually is like it'll like simplify pretty nicely. But if you factor the numerator, you would see that's going to be x plus 2, x minus 1, like what multiplies the -2 adds up to 1. So you can now cancel the x minus 1s. So I'm sorry, I know this is kind of, I write too big on this, but it would just be x plus 2 over 2. So you always want, like, sometimes after you like add your numerator, you want to just see, does it factor at all? Because you might have some things that cancel out. But that would be our final answer, that x plus 2 over 2. There's really not anything you could do with that. I mean, if you wanted to, you could write it as 1/2 x plus 1. But honestly, it's fine how it is, in my opinion. One thing they asked in the directions that I didn't really like read at the beginning, but it says, so what is the sum? So we found our sum. They want us to state any restrictions on the variable. So basically, what couldn't your x value equal? So that's like, if you think back, if you remember when we talked about holes and vertical asymptotes, so the restrictions on the variable, like what can't you plug in for x is basically what that means. So our x couldn't equal 0. Oh, wait, and I wrote this wrong. I wrote a 2 instead of an x there. What was I doing? Sorry. Just got that. My bad. But x can't equal 0, obviously. And from that hole that canceled out, it also couldn't equal 1. Like both of those would make the denominator equal 0. So those are our restrictions. Basically, what couldn't your x value have equaled? So how about you guys give question B a try? See if you can kind of follow these steps. So try and factor your denominator. Get your common denominator by multiplying both fractions by the missing pieces maybe that they need in the denominator. And then add your function. See if you can give this one a try. I'll pause the video. Just kind of make sure we're understanding. So the first thing you always want to do is factor out your denominators, because that's going to let you kind of figure out what your common denominator between the two functions or between the two expressions or the two fractions should be. That's a difference of squares for the x squared minus 4. So that's x plus 2x minus 2. And then there's really nothing you can factor on the second fraction. So you want to think about, so now what we need to do is we need to figure out what our common denominator will be. So maybe I'll kind of word it a little bit different. Our common denominator, so I'm just going to put, I'm even just going to put CD. It's technically our least common denominator, but our common denominator, if you look, both of these have an x plus 2. So to get a common denominator, the only thing I really got to add to the second one is this x minus 2. Like if I had the x minus 2 on the bottom here, that would be the same denominator, right? So, but I can't just add that on the bottom of this fraction without multiplying it to the top as well. So I got to multiply the second fraction by x minus 2 over x minus 2, which you're really multiplying it by 1. You're not changing the problem. So this first fraction, we're not changing anything. So I'm just going to copy that down. But the second fraction, if I multiply that 1 times x minus 2, well, that's just going to be x minus 2 on top. And then we'll have the same denominator. So now that these fractions have the same denominator, we can add them. And remember, when you add fractions with the same denominator, you just add the top, keep the same bottom. Like 1/2 plus 2/2 is 3/2. You know what I mean? Like when you add fractions with common denominators, you just add the top, keep the same bottom. You know what I mean? You don't add, like, that's just one, like, just think about like basic fractions. I know it's probably been a bit since you've been like doing a lot of those by hand, especially with calculators being so available. But if you add the top, x plus x would be 2x. That minus 2 is just going to come along the top. So just make sure when you're doing this, you're adding these things together on the top. And then you keep the same denominator. And this is really our answer, but we just want to check, can we factor our numerator, like just to see if anything cancels out? I mean, the only thing you can do on the top is factor out a 2. And you're going to see it, nothing really cancels from here. Like you don't have any like common binomials or anything. So that would be it in this problem. Remember, it does say state any restrictions. Basically, like what can't you plug in for x? So like in this problem, you couldn't plug in -2. You couldn't plug in +2. Like that would make your fraction equal 0 on the bottom. Basically, where would you have any, if I know it's been a little bit of a gap, but where would you have any holes or where would you have any vertical asymptotes? Those would be restrictions on the variable. But if I'm confusing with like what the x can't equal part, like my big focus is on like the sum, like our fraction we got here. But just keep in mind, even when you're adding or subtracting, sometimes there will, those restrictions we talked about before would still apply. Okay, so that's addition. We're going to look at, next we're going to look at a couple subtraction question. Really the process is no different when we're doing these. Yeah. Because when we, okay, so when we were, let me see if I can like highlight. When we were here, we're adding the top of our fractions, right? So it's really 1x plus 1x minus 2. So when you add these together, I mean, you just, like, it's really just, so you just add the two x's or combine like terms. So that's how I got the 2x minus 2. Does that help you see that? Okay. So let's look at some subtraction questions. Like, and if you're having trouble with the addition, these examples, I mean, it's like I said, the same process. So hopefully this will even help you kind of with these if I'm losing you at all. So let's look at this first question. So the same kind of general steps are going to be the same. You want to factor your denominator because you want to, that's going to allow us to better see what we need to change or what we need to multiply the fractions by to get a common denominator. So we want to factor the denominators. I'm just going to like abbreviate that. So, I mean, this first fraction is really not anything to simplify. For the second one, you could, what multiplies the 2 adds up to -3? Well, that would be x minus 2, x minus 1. So we want to get a common denominator before we do any subtraction. So if you kind of look at like at our bottoms right now, like they both got this x minus 2. The only thing the first denominator is missing is that x minus 1. So I got to multiply this, because if I multiply this by x minus 1, I got the same bottom. But I can't just multiply the bottom of a fraction. I can't just change the problem. So I got to multiply the top by that as well. And the reason is because x minus 1 over x minus 1 is really 1. That's like, we're really not changing the problem when we're doing that. I mean, we're modifying it in a way, but we're not just changing it for no, like without reason, like our way we can't. And when you do this, it's kind of up to your point if you want to keep it in factored form or FOIL, but you really kind of want to FOIL because we're going to be combining like terms. So you really do kind of want to FOIL this out on top. So like x minus 1 times x plus 3. If you FOIL that, like you'd get x squared plus 3x. Like here, I'll kind of write it on the side, but if you can kind of FOIL it in your head, it might be a little bit helpful to save a little bit of writing. But that would be x squared plus 3x minus 1x minus 3. So basically on top, we would have, if you combine those like terms, that would be this. And then we have our common denominator. I'm just going to write it the same order as the second one, though. So then we have minus 6x minus 7 all over this. We do need to be really, one thing with these subtraction problems, and this is where a lot of people are gonna like, if you're gonna mess up one of these problems, it's probably with the subtraction. You gotta be really careful. You're subtracting this quantity. So when you subtract, you almost gotta switch your signs. You're gonna subtract 6x and you're gonna subtract -7 in a way. So when we subtract this here, I'm gonna erase this because that was just me foiling it out. So we're going to have x squared plus 2x minus 3 all over just one fraction now. But when you subtract this, remember, it's going to be the opposite of, you're subtracting both of those parts. So it's going to be minus 6x and it's going to be minus -7. You almost got to distribute that minus sign. So it's really going to be a plus 7, not a minus 7. Because you're subtracting that quantity. So I don't know if that, so that's like one thing you got to be really careful with because you're minusing this whole top. So minus 6x, but minus -7, like minus -7 is really a plus 7, if that makes sense. But from here, we're just going to like kind of clean it up a little bit, like combine our like terms. I write too big. I'm just going to write it down here. But 2x minus 6x would be minus 4x. Negative 3 plus 7 would be plus 4. I write way too big for this. If you factor, now we just want to factor our numerator just to see if like anything cancels out, like or simplifies. That's a difference. Oh, does anything multiply to positive 4? And add up to negative 4? Well, yeah, negative 2 and negative 2. Don't worry. So you can see you can cancel out one of your x minus 2s. Sorry, I can't like, I write too big on like for this. But this would be your final answer. And if you looked like, it's not just like in your final, your bottom, you couldn't have had a positive 2 because that would have been a problem with your whole. And then you also can't have 1 because that would give you a vertical asymptote. So 2 and 1 you couldn't plug into this function because the denominator would be equal to 0. Everything else would be fine, but just 2 and positive 1 would not be good because it would make your denominator equal 0. So with subtraction, you do got to be really careful when you're when you actually get to the subtraction part. You're subtracting the quantity, so you almost got to distribute that minus sign. It's like a really easy mistake to make with these. Let me look at this part B. If you want to try part B, just one tip, when you get to the end, your numerator is not going to factor. Like you're not going to be able to like really cancel things out at the very end, but like you should be able to factor out your denominators, get a common denominator. But just a heads up, when you get to the very end, it's not going to really like factor. Like you're not going to be able to simplify it very cleanly. Oh, is there any way I can? And like I said, I did post a key to these notes. It's much like neater because I can like, I'm able to do it in the space. So if you're like, if you're getting kind of lost just because my writing's gigantic and I'm like going all over the place, I did post the key to those notes if you're like on your Chromebook and if you don't even want to open that up, if you're having trouble following something I just did, it might be helpful. Hopefully you can kind of check. So one thing, I'm going to try and save myself a little bit of space, but if you simplify the bottom of this second fraction, that would be x plus 5 sure it is goof up, but oh well, it'd be x plus 5, yeah, x plus 5, x plus 1. So for this first fraction, to get this same denominator, you would have to multiply by x plus 1. So you do want to FOIL out the top, or if you recognize that's really like a difference of squares, like factor, it's almost like you're going backwards. So it would, like that top part there would really just be x squared minus 1. You would see if you FOIL it out, you're going to get plus 1x minus 1x, they cancel out. But if you recognize that's really the difference of squares. You see that kind of going backwards. So like that numerator for this one would just be x squared minus 1 over our common denominator. I'm going to just write it in the same order that it is for the second one. So now we can actually subtract this, but just be careful when you subtract, you really got to distribute this minus sign. So you would have x, I'm going to kind of write it in order like a standard trinomial, but you'd have x squared minus x, and then you're going to have a minus 3. So minus 1 minus 3, that would be a minus 4 up top. And then keep the same denominator. And if there's nothing you can do to really factor out that top, nothing multiplies to -4 and adds up to -1. I mean, you could like factor it out like with quadratic formula, but it's going to be messy. Like it's not, nothing's going to really come out of it that's going to be super helpful that I'm aware of. Maybe, I mean, maybe if there's like an imaginary, I don't know, but I don't believe anything really simplifies. I could be, maybe if you did do it and you got your complex solution, because what nothing multiplies a -4. I think it's just a decimal answers. I really don't think it would work out nicely, actually. So basically, you would just keep it because you can't simplify the top to cancel really anything out. So what your restrictions, you can't have -5, you can't have -1 because that would make the bottom of your fraction equal 0. Those would both be vertical asymptotes. You kind of remember back from 8.3. So I mean, addition and subtraction are very similar, like I said, but with the subtraction, you gotta be really careful when you subtract. You gotta really distribute that minus sign because you're subtracting the quantity of that second fraction. So be careful about that. That's a very easy mistake to make when you're doing a subtraction question. But that's it for addition and subtraction. The last thing we're gonna look at in 8.5, and then we'll call it a day. I'm sorry, I'm going to erase some of this work that just went all over the place. We're going to look at complex fractions. So complex fractions are basically, but complex fractions are basically fractions with fractions. Everyone loves them. By far the favorite topic every year. But it's basically, you're going to have fractions within fractions. One fraction wasn't enough. You put fractions within fractions. So just some examples. I mean, this is like, usually I was like have them look in their textbook, but like you could have something like this. Basically like fractions in the numerator and the denominator kind of thing. Like you have multiple layers of fractions. This would also be an example. Basically, you just can't get enough fractions really. So I mean, and they're down here as well, but so those are just kind of getting you ready for what we're seeing. So how do we simplify complex fractions? Basically the idea is you want to look at all of your individual pieces. And you really want to get a common denominator for them all, if possible. So let me think about, so like for this first one, you almost got, in a way, you got these pieces here. So let me see. Do I really want to do complex fractions right now? And sorry, I just wanted to think the best way to explain it. Okay, the best way I would explain to simplify a complex fraction is you want to look at each piece. So in a way, in this problem, you got, I would say we have 3 pieces. You got like this top x here, you've got this 1/x part here, you've got this 1/y part here. You want to figure out what your common denominator between all 3 parts would be. So, I mean, this x part is really just x/1. This 1/x, and then we have 1/y. So what would be the common denominator between these 3 things? Well, they really don't have anything in common. So basically, you would just have to take the denominator from each piece. So our least common denominator would just be, I mean, technically 1xy, or just really xy. I mean, the 1 doesn't really matter, right? So our least common denominator would just be xy. So we're going to multiply this whole thing by this common denominator. So we're going to multiply the top by xy. We're going to multiply the entire bottom by xy. Basically, we'll distribute it. So on the top, we would just have x² y. On the bottom, we would just have xy/x. We're going to see a lot of these are going to simplify. And then for the next fraction, it would be xy/y. And we'll see on the bottom, basically the x's cancel for the first fraction, your y's cancel for the second one. So this would simplify the x squared y over y plus x. Or you could rearrange that if you like, the x plus y, if you like alphabetical order, I suppose. But basically with a complex fraction, you want to get your common denominator and basically multiply everything by that common denominator. And you'll see a lot of times it will simplify quite nicely. You'll basically get rid of your fractions within fractions, and you should end up with like a single fractional expression, if that makes any sense. Let's look at B, and we're going to see B gets a little bit more going on. But basically, you want to look at all of your denominators. You want to figure out what would your common denominator between all four of these parts or all four of these fractions. Like, what would our least common denominator be? So if you kind of look, you kind of want to just list what they have uniquely between them. So I mean, we're going to have an x. We're going to have an x plus 1. And we're going to have an x minus 1. And I don't put x plus 1 twice because like both of these parts just have a single x plus 1. Does this make sense how I'm getting this least common denominator between them? But so once you get this least common denominator, we got to multiply every fraction basically by this. So we're going to multiply the top by this. And it might seem a little bit crazy, but we're not going to FOIL this out. So we're going to keep this just in factored form. And we're going to multiply the bottom by this. Oops, and I wrote that wrong on the top. That should have been x minus 1. So you kind of want to just do like one fraction at a time. So if you think about like, it's almost like crazy. I almost don't want to even write it. But if you think about it, like with this first fraction, basically the x's would cancel out, and then you would just multiply the top by that x plus 1 over x minus 2. I'll write it for this first one, maybe, just to maybe see that. But basically what's going to happen, you're going to have the x minus 2 on the top. You're going to have the x. You're going to have the x plus 1, the x minus 1, and then it would be over that original x. But that's going to cancel out. So for this first part, I don't know if that makes sense, but this first part, you're really just going to have the x minus 2, the x plus 1, the x minus 1, and then we're going to do the second part. The second part, if you look, here, maybe I'll use a different color. I'll do this part in blue. But if you look, the bottom here has an x plus 1. So that's going to cancel out this x plus 1. So you're going to have the 2 that you already had up top. Then you're going to have the x, and then the x minus 1. And then we're going to start working on the bottom. So I'll do this part in green. So if you look on the bottom, you have an x minus 1. So that's going to cancel out this part here. Like you put that on the top. So in this part, we're going to have the 3 on top. We're going to have the x and the x plus 1. And then it's minus. And we're going to do this last fraction. Let me just rewrite this. Oops, let's keep it in red. But if you look, I'll do this part maybe in purple. If you look on the bottom, it's got this x plus 1. So that's going to cancel out here. So on the top, we already had a 1. And then the x, and then the x minus 1. And this is really it. I'm trying to think. You could, I guess, if you're like a crazy person, you could like FOIL this all out. Maybe you could factor something out. But it's really not going to simplify too much more from here. I mean, I would just keep my answer in this form. But I mean, technically, you could FOIL that out. You could get like standard form over standard form, but I don't see a lot of benefit to doing that, especially because we're not doing anything with this. So, I mean, you could multiply this all out. You could multiply this out, combine like terms. You could do the same thing on the bottom, but we're just going to keep it like it is. But if you had to do more, now this is in a form where you could, instead of having all those crazy fractions. So I'll have to see I don't know what Delta Math has.